Okay, so this is exercise 15.6, okay, on differentiation, and we're going to start with this question here. Now x plus y equals to 13, and where x and y are positive numbers, they're bigger than 0. If w equals 2x plus 3y plus x multiplied by y, write w as a quadratic in x. Now write w as a quadratic in x means that you want to know y's in this equation here. So we got to get rid of those y's. Now how we get rid of those y's is we bring this x over to the other side and we're going to get y equals 13 minus x. So we can then do is replace all x's in this equation here, all y's, sorry, with 13 minus x. So we're going to get plus 3 times 13 minus x, and then we're going to get plus x times 13 minus x. And what we should have here is 2x plus 39 minus 3x plus 13x minus x squared. That's when I multiply these out. And then what we're going to get is 2x minus 3x is minus x plus 13x is 12x. So we're going to have a minus x squared first, minus x squared plus 12x plus 39, okay, equals w. So that's the quadratic equation written in terms of x only. Okay. So sorry, excuse me guys, this is exercise 15.4. Okay. So what we're going to get next is w. Okay, so we're going to have to find out, calculate the maximum value of w. Now, maximum is a turning point. So this is a quadratic function here, okay, and it's a minus x squared, so it means it's represented like this on the graph. So you have an xy axis and you have a maximum point here. So what we have to do in differentiation is dw dx is going to represent a formula for the slope, and it will tell us the slope at any given point. We want the slope to be equal to 0 because it represents the maximum point. So what we're going to get is minus 2x plus 12, because bring the 2 to the front, drop the x, so when you differentiate it's minus 2x plus 12. This has to be equal to 0. Bring 12 over the other side, minus 2x equals minus 12, x therefore equals 6. Okay, so x equals 6 is the x value for the maximum value of w. Now we got to find out what is w. Well, w is equal to minus x squared plus 12x plus 39. It's a quadratic equation represented by this, and we know that the x value is equal to 6. Now we have to find out what the w value is here. Okay, so we're going to get w equals minus 6 squared plus 12 times 6 plus 39. Put that into the calculator, we get minus 36 plus 72 plus 39. Okay, and what we should get, so calculate the maximum value of w. So w therefore is going to be equal to 75 meters squared. Okay, so moving on. A garden is to be L-shaped as shown. Its perimeter is 36 meters. Express y in terms of x. So y in terms of x, okay? So what we're going to do is we're going to get the perimeter of this. Okay, so perimeter equals, so what we're going to do is we're going to add this together. So this is going to be x, y. This side here is going to be x plus y because it's x from here to here and y from here to here. And then we have it's x from here to here, and then 2x from here to here. So this other side is going to be 3x. So now we know the perimeter is going to be equal to, going this way, x plus y plus 2x plus y plus 3x. Then we're here plus x plus y. Then we're going to count how many x's we have. So p therefore is going to be x, 3x, 6x, 7x. So it's going to be 7x, y is going to be 1, 2, 3, plus 3y, and this all equals 36. Okay, so 36 meters equals 7x plus 3y. And what we're going to do is move the 7x over to your side. And we're going to get is 36 minus 7x all over 3y. Or all over, so equals 3y. And then we're going to divide by 3. And then we're going to get y equals 36 minus 7x all over 3. Alright. Express the area of the garden in terms of x. Okay, so the area of the garden, now, the area of the garden is, I'm going to split it up into two different sections here. Okay, so the first section I'm going to spread up into is this rectangle here. Now, this rectangle has a length of 3x and a width of y. Remember, area equals length multiplied by width, which is 3x multiplied by y, which is going to get me 3xy. Next thing is we're going to do the area of this blue part here, which is length of x and width of y, which is going to get me xy. Add them together, I'm going to get 4xy. Area equals 4xy. Now it says it wants the area in terms of x only, okay, so what we're going to do is we're going to substitute in the y value. So we're going to get 4x multiplied by 36 minus 7x all over 3. And what we should get here is a equals 4 times 36 is 144x minus 28x squared all over 3. Now, what it says is find the value of x and the value of y to maximize the area of the garden. So to maximize the area of this garden, we got to find its turning point. Remember, max means turning point. So I'm going to find dA dx. Now to do this, I'm just going to, before I do dA dx, I'm just going to change around the values here. So I'm going to get 144x all over 3 minus 28 over 3 x squared. Okay, so what's going to happen here, I'm going to differentiate. And to differentiate, what should happen is the x drops, so that leaves 144 all over 3. And then bring the 2 to the front, and we're going to get 56x all over 3. Now remember, this has to equal 0. So what this now means is that 56x over 3 must equal 144 over 3. When I move to 56x over 3, cancel the 3's, x is going to equal 144 all over 56. So we get 144 over 56. And what we get here is 18 over 7. X equals 18 over 7 meters. Now that we have that, what's going to happen next is that we're going to figure out what y is. Okay? Well, the value of x and value of y, so we need to find out what y is. Okay? So y is 36 minus 7x over 3. So 36 minus 7x all over 3. So what this is going to be is 36 minus 7 times 18 over 7 all divided by 3. That's what y will be equal to. The 7's cancel, and we're going to get 36 minus 18, which is going to be 18 over 3. Y therefore is 6 meters, and x is 18 over 7 meters. Okay, next question. 7. The cost of running a machine is given by C, which is the cost, equals 17V multiplied by V minus 5 plus 80, where C is cent per hour and phi is the number of revolutions per second. Find the number of revolutions per second that will minimize the cost. Well, if I was to multiply this out, what I'm going to get is 17V squared minus 5 by 17 is 18V, that's 85V plus 80. Now, what I can tell you about this graph right here is it has a positive phi squared, which means it's a U-shaped graph, and it means it has a minimum point. To find this minimum point, we get the z to v. Remember, when you differentiate, you get the slope at any point. And what we want to find out is what is the slope when it's at its minimum. So we're going to get 34v minus 85. And this has to be equal to 0. Now we know that 34v equals 85, and phi is going to equal 85 divided by 34. Now I'm pretty sure they're both divisible by 17, but we'll just check that out. 85 divided by 34. and we get is 5 over 2, or 2.5 revs per second. Okay, so this one here is question 7. Okay, so it's going to be 2.5 revolutions per second. Revolutions per second. Okay, moving on to number 9 now. Okay, at a speed of x kilometers an hour, a motorbike can cover y kilometers on 1 litre of petrol, where y equals 5 plus a half x plus 1 over 30x squared minus 1 over 450x cubed. Calculate the maximum distance that the motorbike can travel on 16 litres of petrol. Okay, so what we need to realize here is that this graph represents y kilometers on 1 litre of petrol. We have to find the speed that gives the maximum. Okay, so what we're going to do is we're going to differentiate, do y dx, and what we're going to get is the 5 cancels, x becomes a half, the 2 gets multiplied by a 30th, so 2 times 1/30th is actually a 15th, so it's going to be a 15th x. And then we're going to multiply by 3, and we're going to get minus 3 over 450 x squared, and that's going to be minus 1 over 450 x squared. Now, what's going to happen here is basically, this is a quadratic equation, and we need to figure out when it's equal to 0. Okay, so when it's equal to 0, what we're going to do is we're going to have to get rid of these fractions here. Okay, so I'm going to turn all of them into 150s. So I'm going to multiply the top and bottom by 75. That'll turn that into over 150, and multiply the top and bottom here by 10, and that'll turn it to over 150. So I'm going to get 75 plus 10x minus x squared equals 0. Alright, and it was all over 150 technically, but when you multiply the 150 upwards, it disappears. Okay, so that's why that's gone there. Now that we've done that, what's going to happen next is we're going to multiply both sides by minus 1, and I'm going to get plus x squared minus 10x minus 75 equal to 0. I'm going to factorize this into x minus 15, x plus 5 equal to 0. Now x equals minus 5, or x equals 15. Now I'm pretty sure that it's going to have to be x equals 15. The reason why it's going to be x equals 15 is it probably needs to have a positive speed. You can't really have a negative speed, okay? But I suppose the other thing we have to check out is that, like, it specifies maximum distance, okay? So if it specifies maximum distance, I should probably differentiate a second time and make sure that it gives me a maximum. So we know that dy dx ends up to be a half plus 1 over 15x minus 1 over 150x squared. So let's do the second derivative test and see if we have a case here. Now what's going to happen is the second derivative test is going to give me 1 over 15, and then the 2 is going to multiply in, it's going to be 1 over 75x, because minus 2 over 150 is the same as minus 1 over 75x. Now I'm going to replace x with 15 and see what happens. So I'm going to replace x with 15, I'm going to get 1/15 minus 15 over 75. Okay, and what we can find out about that is that it's going to be a 15th minus a 5th, and that's going to be less than 0 because a 5th is bigger than 15. So this means it's a max. So we're happy enough with that being the max. Okay, so because it's 1 over 15 minus 1/5, and what we get there is minus 2 over 15, which means it's a maximum. Okay, so that's a max. Okay, so now that is done. Okay, we got to find out how much distance it will cover. Okay, and we just want to verify that the minus 5 is a minimum. So if we were to put in minus 5 for this one here, we would have got plus a 5th, or sorry, we would have got plus 5 over 75, which would have made a min. So we verified that that's a max and the other one's a min. Now what we're going to do next is we're going to replace x equals 15 into the original equation. So when we do this, we're going to get, that's going to be 15, it's going to be 15 squared that's going to be 15 cubed. So we'll see what we get here. So 5 plus a half 15. A half 15 is 7.5. Okay, so I won't waste time on that. Then plus a 30th, 15 squared. So 1 over 30, 15 squared. And then finally minus 1 over 450, 15 cubed. Okay, now the answer to this is going to be 12.5. Okay, so y equals 12.5. Now remember what y stands for: kilometers per litre. So that's kilometers per litre. We have 16 litres, so we've got to multiply this answer by 16. So what is 12.5 multiplied by 16? There we have it. 200 kilometers is what we can do. Okay. Moving on. 11. A closed rectangular box is made of metal of negligible thickness. Its length is 3 times its width. The volume of the box is 288 centimeters cubed. If its width is x, show that its surface area A is given by A equals 768 divided by x plus 6x squared centimeters squared. Now, the first thing you're going to notice about this formula is there's no h. So that means we're going to have to find somehow to get rid of h. Now, surface area represents the area of all 4 sides. Or say all 6 sides. Okay? So what I'm currently doing is writing down all 6 sides. Now, this area of 1, area 1 and area 2, okay? Area 1 and area 2 are 3x in length and h in height. So their area is going to be 3xh plus 3xh. Because that's what it is. It's 3x here and h up. Now I have the blue areas 3 and 4. Blue areas 3 and 4 are going to be h across x up. So 3 and 4 is going to be plus 3x, or sorry, plus 3h, sorry, plus xh plus xh. And then finally I have areas 5 and 6, which are the base sides, which is going to be 3x across and x up. So it's going to be 3x squared each time. So area 5 plus area 6 is going to be plus 3x squared plus 3x squared. So when we add everything together, we know that the area now equals 6x squared. And then we're going to have 6xh plus 2xh, which is 8xh. Now, it specifically says that the area can have no h's in it, so we have to find a way to get rid of h. Now, what piece of information I haven't used yet is I haven't used anything to do with my volume. Now, remember, volume of a cylinder, volume of a box, volume of a box is length by width by height. So it's going to be 3x multiplied by x multiplied by h. That is 3x squared h. 3x squared h equals 288. Get h on its own, which means bring the 3x squared underneath. 288 divided by 3x squared is what h equals. Now we're just going to, out of chance, we're going to see if this 288 will divide by 3. As it turns out it does, it's 96. So h equals 96 all over x squared. Replace this h into the formula. So we're going to get a equals 6x squared plus 8x multiplied by h, which is 96 over x squared. And what we're going to get is a equals 6x squared. 8 times 96 is, I suppose, going to be 768. Then x squared divided by x squared leaves you x. And there it is. There's our area right there. Okay. If the surface area of the box is to be a minimum, find the dimensions of the box. So I have to find out the length, the width, and the height. Remember, it says minimum. Okay, minimum. Okay. Now this graph here, if I was to graph this out, this is a positive x squared, which means it's a u-shaped function, which means it has a minimum value. Once again, differentiating represents the slopes, and I want to find the slope when it equals 0. Hence, to find out the x value, for when it's the minimum. The y-axis represents a, the x-axis represents x. So we're going to get the a dx, and what's going to happen here is we're going to get 12x. Now I'm going to change 768, I'm going to change that to 768 x to the minus 1. Because remember, 1 over x equals x to the minus 1. So what we're going to get when we differentiate this is the minus 1 comes in and becomes minus 768. Take another 1 away from the power, all over x to the minus 2. Okay, and this here has to be equal to 0. So we're going to get 12x minus 768. Now x to minus 2 is, believe it or not, over x squared. Okay, and this all equals 0. We're going to get a common denominator here, so we need to multiply the bottom by x squared and the top by x squared. So we're going to get 12x cubed minus 768, all equal to 0. Move the 768 over the other side, so I'm going to get 12x cubed equals 768. Then I'm going to divide by 12, so 768 divided by 12, and we get 64. X cubed equals 64. Now there's two ways of doing this. When you bring the 3 over the other side, you can say 64 to the power of a third is one way of doing it, or the other way of doing it is the cube root of 64. Either one gives you the answer of 4. X equals 4. Now if we know x equals 4, so this means the dimensions will be, if x is 4, the width is 4, the length is 3 times 4, which is 12. Now we got to find out what h is. Okay, and we already have a formula for h. H equals 96 over x squared. So h equals 96 over x squared. X is 4, so it's 96 divided by 16. H equals 6. So it's going to be 12 by 4 by 6. Okay, and as you can check out, the volume will still be 288. Now moving on to number 13. The diagram shows a block with a base measuring 2x by x and a height of h. The total surface area of the block is 300 centimeters squared. Show that h equals 150 minus 2x squared all over 3x. Well, like last time, we're going to get a surface area. So area equals area of 1 by area of 2. Which area 1 and area 2 are 2x across and h up, which gives us 2xh. So 1 plus 2 is going to be 2xh plus 2xh. The next one is area 3 and area 4, which are the same. And area 3 and area 4 are x by h. So you're going to get plus area 3 plus area 4 plus xh plus xh. And then finally you're going to have area 5 and area 6. Area 5 is 2x across and x up, giving us 2x squared. So it's going to be 2x squared plus 2x squared. So that's going to be area 5 plus area 6. Now, the area therefore is going to be 4xh plus 2xh. Well, that's going to give me 6xh. And we have plus 4x squared. Now, what we're told about the area is 300. So we can say that 300 equals 6xh plus 4x squared. Let's get h on its own. So it's going to be 300 minus 4x squared equals 6xh. Divide across by 6x. Now I'm going to do it in two separate parts. I'm going to divide this part by 6x and this part by 6x. Suppose I should. And what I'll get is I'll get 50 over x. Because 300 divided by 6 is 50. And then on the other one I'll get 2x over 3. Because this x cancels with this one here. And 4 over 6 is 2 over 3. Now I need a common denominator here. So I'm going to cross multiply that by 3. So we're going to multiply. Sorry about that. We're going to multiply the bottom one here by x and this one by x, and then we're going to multiply this one by 3 and this one by 3, and we get 150 minus 2x squared all over 3x equals h. I believe that's what we're asked to do. Grand. Express the volume of the block in terms of x. Well, the volume of the block, as we can see here, is going to be 2x by x by h. Volume equals 2x by x by h. And what we're going to get here is going to be 2x squared. 2x squared h. Okay, and we know that h is 2x squared times 150 minus 2x squared all over 3x. We'll multiply that out. We're going to get phi equals 300x squared minus 4x to the power of 4 all over 3x. We're going to break that up into 300 over x squared over 3x, and we're going to make that minus 4x4 over 3x, and then we're going to just get rid of the x's. So the 300 divides by 3 to give you 100, x squared divides by x to give you x, and then x cancels with this one to make it 3, so we get minus 4x3 over 3. Now, next thing we're asked is find the value of x that gives the blocks a maximum volume and calculate this maximum volume. So we have to find out what happens. So we have to get the VDX, and what we're going to get is 100. So I'll change it to 100. Bring the 3 to the front, and we're going to get minus 3 times 4 over 3. Take 1 away from the power is x squared. Now 3 cancels with the 3, so we're going to get minus 4x squared equals 0. So we're going to bring the 4x squared over to the other side, and what we're going to get is 4x squared equals 100. X squared must equal 25. X can be either minus 5 or plus 5. Can't be minus 5 because it's a measurement. X equals 5. I need to make sure this is a maximum, so I'm going to get the second derivative. The second derivative gives me minus 8x, and x equals 5, so that gives me minus 40. Minus 40 is less than 0. When the second derivative is less than 0, it is going to be a maximum. Okay, so now we've got to find out the volume. Well, the volume equals 100x minus 4 over 3x squared. So all I need to do is replace in the number 5 into this formula. So it's going to be 100 multiplied by 5, which is 500, minus 4 over 3, 5 cubed, and what we're going to get here is 1000 over 3, or 333.3. So what is this question turned in? So it's 1000 over 3 centimeters cubed. So 1000 over 3 centimeters cubed. Maximum volume 1000 over 3 centimeters cubed. Value of x is 5. Okay, moving on to number 15. The width and length of a page in a book are x centimeters and y centimeters respectively. If the area of the page is 96 centimeters squared, express y in terms of x. Now, what's going to happen here? Sorry, excuse me. So, if the area of the page is 96 centimeters squared, express y in terms of x. It is necessary to leave a margin of 2 centimeters at each side of the text and 3 centimeters top as shown. Okay, so the full length is x by, the full area is x multiplied by y. X multiplied by y is 96. Therefore, y therefore equals 96 all over x. Okay, so y in terms of x. Oh, sorry, that's it done. It is necessary to leave a margin of 2 centimeters at each side of the text and 3 centimeters top and bottom. So that's 3 here, top and bottom. express in X and Y the area of the page available for text. Okay, so available for text, okay, so it gets it's X from here to here. What happens is it gets 2 taken away from it on both sides. So that's going to be X minus 4 is the length from here to here. And this one here is therefore going to be Y minus 6, because it gets 3 taken from here, 3 taken from here is Y minus 6. Now it's going to be X minus 4 multiplied by Y minus 6 is the area for text, or A subscript T. So we're going to get XY minus 6X minus 4Y plus 24. Now, Y equals 96 over X. So X times 96 over X minus 6X minus 4 into 96 all over X plus 24. And what we're going to get is 96 minus 6X. 4 times 96 is going to be 384, so minus 384 all over X, and then what we're going to get is plus 24. So this equation for the area now turns out to be 96 plus 24, which is going to be 120. So it's going to be 120 minus 6X minus 384 all over X. Okay, so that is the area of this. Okay, now find the dimensions of the page if the area available for text is a maximum. So if it's a maximum, we once again got to differentiate it. Now I'm going to change this 384 over X to 384 over X to the minus 1. Makes it easier to differentiate. Then when I differentiate, what's going to happen is the 120 disappears. This turns into minus 6. And then I'm going to get, it's going to be multiply minus 1 by minus 384, which is going to be plus 384. Take 1 away from the power, and we're going to get X to the minus 2. This equals 0. So then bring the 6 over the other side, and what we're going to get is 384 all over X squared, because remember that's what X to minus 2 means 1 over X squared. And then we're going to bring the 6 over the other side, and then we're going to get 6x squared equals 384. Divide by 6, so 384 divided by 6, we get 64. We're going to get x squared equals 64. This means x got to be equal to 8. Okay, so find the dimensions of the page if the area available for text is a maximum. So x equals 8. So if x is equal to 8, this means that y equals 96 divided by 8, which is 12, and 8 times 12 will give you 96 centimeters squared, or it's an 8 centimeter by 12 centimeter page. So just ask for the dimensions of the page, not the actual area of that page.